Question 11. A sampling method where each outcome has an equal chance of being selected is most accurately referred to as random sampling, systematic sampling, or sampling distribution. So sampling distribution is not a type of sampling method. The sampling distribution is basically just going to be our statistics about the sample that we did end up selecting. So we can rule out C right away. B, systematic sampling, and A, random sampling now. Systematic sampling is going to be where we're choosing our sample based on some interval. So we're choosing some every fifth observation or every third observation within the population that we have. And so it's not going to be an equal chance necessarily of being selected. So we can rule out B, and then we can go with answer A, random sampling. And this is the key feature of random sampling. Each observation has an equal chance of being selected. Answer A. Question 12. Which of the following is least likely a method that an investor uses to assess geopolitical risk? So we've got A, velocity of its impact. I think we can rule this out since we're looking for least likely, and we're going to want to know the velocity of the impact. So the speed at which the impact may occur. We're going to want to know the speed at which something would occur if a geopolitical event happens. B, the likelihood of its occurrence. This also sounds like it would want to be one of our criteria. We would want to know the probability of something happening, and whether that's low or high might determine how we prepare for that, whether that's in our portfolio or otherwise. And then C, recurrent nature of its impact. I think that's going to be our best answer, since geopolitical risks and events are normally not going to be, or hopefully will not be, recurring, and because they're going to be they're going to be a lot more dynamic and different in how and what they happen. So you might have wars that break out very frequently or often, but it's not going to be recurrent in the sense of the countries involved could be very different. The type of weapons and war that they're in is going to be different. So normally it's not going to be preparing for a recurring thing happening, but more so probability of an event happening and how quickly that'll impact markets or economics and such. Answer C. Question 13. Janice McIntosh is performing statistical analysis on the equity market of Algeria. She is attempting to predict the effects of a recent technology regulation on the forecasted EPS of software houses. She collects financial data concerning 40 software houses. McIntosh calculates sample mean and sample standard deviation of 33.05 and 0.1185, respectively. Based on her collected sample, she forecasts that the EPS value is expected to equal 35.2. Based on the data collected and using the central limit theorem, the standard error of the sample mean is closest to. So we've got a lot of numbers in here, but there's really only two key ones that we need to pay attention to for standard error. And that's going to be standard deviation, which is given at this right here, so $0.1185. And then the number of observations in our sample, square root of that, which is going to be 40, given at 40 software houses. And so we take that standard deviation divided by the square root of our observations. We get 0.0187, which is going to line up right there with answer B. Question 14. Chris McKay has a portfolio that consists of 75% equities and 25% bonds. Equities should return 18% and bonds return 9%. The correlation between equities and bonds is 30%. If McKay's strategy related to the bonds consists of keeping them until maturity, his portfolio's rate of return is closest to. So we're looking at rate of return here. So to calculate rate of return, all we need is 75% equities. So we're going to do 0.75 times their return of 18%. And then we're going to do 0.25 bonds and multiply that by 9% return. We do not need correlation to calculate expected returns. That's only going to be used to calculate expected volatility of the portfolio. And also keeping them till maturity is also not relevant information for us. So we've got some red herrings here, if you will. But the expected return calculation is pretty straightforward. 0.75 times 18 plus 0.25 times 9. So it's just a weighted average of the portfolio's expected returns. And that's going to get us 15.75. Answer C. Question 15. From a population of 10,000, a researcher chooses a sample of 1,000 observations. If the population's standard deviation is 100, the standard error of the sample mean is closest to. So our formula here is going to be standard error is equal to standard deviation divided by n, the square root of n. The tricky part here is what n do we use? Do we use the population or do we use the sample? And the key here is we want to know the standard error of the sample mean. If it said the standard error of the population, then we would use 10,000, but in this instance, we're using 1,000. So we'll have 100 as our standard deviation plugged in the numerator, and then that's going to be divided by 1,000, square root of 1,000, which gives us 3.1623, and that rounds to answer B, 3.16. Question 16, consider the following information. Portfolio A's variance of return 45, portfolio B's variance of return 42, and correlation of returns at 0.48. The covariance of returns between portfolios A and B is closest to. So our formula here is going to be covariance of A and B is equal to the standard, or is equal to correlation, which we're given at 0.48. And then we're going to multiply that by standard deviation of A, which this is where it gets a little tricky because we're not given standard deviation, we're given variance. So we're going to need to take the square root of 45, and then we're going to multiply that by standard deviation of B. Again, so we've got variance of B at 42, so we'll do 42 square root. So we've got 0.48 times 45 squared times 42, sorry, not 45 squared, times the square root of 45 times the square root of 42 gives us 20.8676. Right there, answer A. Question 17, a type 1 error is made when? A, the null hypothesis is rejected when it shouldn't be rejected. B, the alternative hypothesis is rejected when it should be rejected. Or C, the null hypothesis is accepted when it should be rejected. So B, I would say, doesn't really make sense right off the bat because we're not normally rejecting the alternative. We're rejecting or failing to reject the null. So I think we can rule out B right off the bat. So it's, are we rejecting when it shouldn't be rejected, or are we accepting it when it should be rejected? So I had Perplexity make this little chart for me to kind of summarize here. So for type 1 error, this is when we're going to be rejecting a true null hypothesis, or maybe not true, but a null that shouldn't be rejected. And essentially this happens when our null hypothesis is true. Type 2 error is when we fail to reject a false null. So our null hypothesis is false in that instance. So type 1 error, that's going to line up with our answer A, rejecting the null when it shouldn't be rejected. Answer A. Question 18. The use of concentration ratios to estimate whether a potential merger should be blocked due to the potential of increasing monopolistic behavior. A, may overstate the risk if there are low barriers to entry. That sounds like a true statement so far. If we have high market concentration currently, but there's low barriers to entry, that might just mean that we're in a newer or early on market, and not a lot of new companies or competitors have come into the space yet. So it may look like the industry is really concentrated at the moment, but if there's low barriers to entry, then that should lead to increased competition and less monopolistic behavior. So A sounds pretty good so far. Let's look at B and C, make sure we can rule those out. B, may overstate risk if the industry is too broadly defined. So in this case, this isn't going to overstate risk. It's actually going to understate risk. And that's because if we're defining this really broadly, the monopolistic nature of certain niches or products within this broad definition could be monopolies, but we're not seeing it because we're including too many different types of products within this industry. So this would likely be an underestimation of risk, not an overestimation. And then C, may understate the risk if the products are highly differentiated. I think this is going to be kind of similar to B. If products are highly differentiated, it may look like certain companies have a monopoly within an industry. However, people may be using those products differently or for different things. And so if you have highly differentiated products, the merger between the two may not actually be taking market share within that industry. It may more so be that they're a part of different kind of industries or use cases. So I think we can rule out C, stick with A as our best answer. May overstate risk. Question 19. Jennifer Hollanda is a long-term trader who purchased a PetroCo share at the price of $50 at the beginning of the year, assuming that the share price increased to $100 in the first year, decreased to $50 in the second year, decreased to $25, and increased to $50 in the third and fourth year, respectively. Volatile share price here. The geometric return of the PetroCo share is closest to. So we have a share price of 50 at the beginning of the year. Share price goes to 100, so that's a 100% return. Decreases to 50 in the second year, decreases to $25, and then increases to 50. So I'm going to show this, how this works out from a returns perspective and actually calculating geometric returns. So remember, to calculate geometric returns, we're going to be doing 1 plus our return. So in the first year, we'll have 100% return. So it'll be 1 plus 1, which is 2. And let me pull this in. So this is going to be that first year return. And then we're going to multiply that by 1 plus the next year return. So the next year return, we got cut in half. So minus 0.5. So it'd be 1 minus 0.5, which gives us 0.5. And then same thing for the third year, we got cut in half again. So 1 minus 0.5. So we get 0.5. And then in the last year, we doubled to 50. So that's going to be 1 plus 1 again. And then we're going to do this to the 1 divided by 4th. So the fourth root, which is to the 0.25. And then we subtract 1, and we see we get 0 for our geometric return. Answer A. Which it was good to do this out mathematically, but when you look at it, the key here is it shows that we had $50 in the beginning, $50 in the end. So it should be a return of 0. Answer A. Question 20. The process of interactions and integration among people, companies, and governments worldwide is most likely referred to as A, cooperation, B, globalization, or C, standardization. This is going to be the phenomenon of globalization. It's not going to be standardization since it's interaction and integration among all these different types of people, companies, and governments. It's not the, doesn't refer to the changing of or kind of standardizing. This would be more so related to maybe something like IFRS or GAAP, where it's kind of providing a standard of accounting principles, but that's not what we're talking about here. And cooperation is certainly needed for globalization, but it's not really the technical term we're looking for here. Answer B.